Hello people, so in this video we take up all the previous year GATE questions related to conversions topic of number system. Look at the first question. You are given that root 224 and the number system in which this number is given has base r, and this is equal to 13 in the same base r. So they are asking the value of the radix. Base is also known as radix. They are asking the value. Okay. Let us look at this problem. I'm not writing the base of the number system. You already know that the base is r. Okay, so I'm squaring both sides. So this becomes 224 and this side become 13 into 13, which is going to be 169. And this side it's going to be 224. Both these numbers are in base r. Now let us apply the conventional formula. We know that if we want to convert this number into decimal number system, we have to multiply with the respective weights of each bit. So what we get is 2r square plus 2r plus 4 is equal to r square plus 6r plus 9. I'm just rearranging this to make a single equation. So this becomes r square minus 4r minus 5 is equal to 0. I'm going to factorize this equation just to find the value of r. Okay, so I'm getting two values for r, which are minus 1 and 5. Since all of us know that the base of a number system cannot be negative, so we neglect this answer. So the right answer is going to be 5. You see, there is an option 5. So this is the right answer. Also, you can verify your answer by converting both these numbers into decimal number system. And see, we're going to check it quickly. See, 224 base 5 in decimal number system is going to be 2 into 25 plus 2 into 5 plus 4. I'm doing it quickly. It comes out to be 64 in base 10, and we all know root 64 is 8. Okay, now look at the RHS. 13 in base 5. This is going to be 5 plus 3, which is 8. Fine. So this means that our answer is correct. Okay, one more thing that you can see here is root 64 I have written 8. Some of you might be thinking that root 64 must be plus minus 8. So this concept is not related to number system, but a general mathematics concept I would like to take. When you write x square is equal to 4 and when you write x is equal to root 4, these are two different things. Okay, see, you already learned that a equation with power n has n roots. We learned this in childhood, right? So here this equation is having power 1, degree 1. So this has to have one root only, and this has degree 2. So this must have two roots. So here you can write x is equal to plus minus 2. And here what do you get? You get x equal to 2 only. You should not write plus minus 2 here. What is the logic behind this? See, take it to the other side. Take this. So it becomes x square minus 4 equal to 0, which you can write as x plus 2, x minus 2 equal to 0, which gives x equal to plus minus 2. But if you are supposed to take root of 4, you should give the answer only as 2. This is not related to number systems anyways, but since here you've got this root 64, you should write only 8. You should not write plus minus 8. Okay, let us move at the next question now. They're asking the binary equivalent of the decimal value 0.25. This has been asked in GATE in 2002. So let us look at this question. So look at the integer part of the given value. The integer part is 0. So the binary representation for 0 is going to be 0. Okay, so the integral part of the binary representation is going to be 0. And what do we do for the fractional part? You're going to multiply it repeatedly with 2. So let's just start this. 0.25 into 2 is going to be 0.50. The integral part that you're getting from this is 0. And you take the fractional part here. You get 0.5 here, and then you again multiply it with 2. What do you get? 1. So we've got a complete integer, so we stop here, right? And we move this way. So what is the final answer going to be? 0.01, which is option B. Okay. Look at the next question now. You're given that 73 in base x is equal to 54 in base y, and they're asking for the possible values of x and y. Just convert these numbers into decimal number system first. Then you can write this as 7x plus 3, and at RHS you get 5y plus 4. So just rearrange. You get 7x minus 5y is equal to 1. Okay. Now the only way to solve this question is to check with the options. You keep the values of the options and check which option is going to satisfy this equation. Since you have only one equation, you can check. One more way to check is the minimum base that this number system must have should be 8. Because this is having 7 as a digit. 7 is a symbol used in this number system, base x number system. So this number system must have base equal to or greater than 8. But see, all the options are having values of x greater than 8 only. So this does not apply. Here also y must be greater than or equal to 6. All the options are having values of y greater than 6. So you check with the options. Keep x equal to 8 and y is equal to 16, and check with all the options. You'll get the answer as D. Just verify. Okay, now look at the next question. This question was asked in GATE in 2004 for 2 marks. This was asked. Okay, so we've already talked about this. Look at the bases of all the numbers. We have to convert a number of base 8 into numbers of base 16 and 4. So you already know the trick. When we have bases in powers of 2, we are going to first convert this number, the given number, in base 2. That is, we are going to convert it into a binary number. From there we convert it into base 16 and base 4. So let's just look at this. We are first going to convert this into a binary number. So we've already learned this. When we have to convert an octal number into a binary number, we're going to represent each digit with 3 bits in a binary. So what is you can start from MSB or LSB, okay? In converting from octal to binary, it does not matter you start converting from MSB or LSB. Here I am starting from the MSB. One representation of 1 in binary in 3 digits is going to be 0, 0, 1. For 2 it's going to be 0, 1, 0. 3 is going to be 0, 1, 1. 4 is 1, 0, 0. 1 is 1, 0, 1. And 6 is 1, 1, 0. So this is the representation of the given number in binary. Now to convert it into a number of base 4, you have to create groups of 2 bits each. We've already learned this logic. 4 is 2 to the power 2. That's why we are going to create group of 2 bits each, starting from the LSB. Right? We have discussed about this in our previous videos. You can check if you have not seen. And 16 is 2 power 4. So we are going to create group of 4 bits each, starting from the LSB. Let's first see for the base 4. I'm going to create group of 2 bits starting from the LSB. So 0, 1 is 2, 1, 1 is 3, 0, 1 again 2, 0, 0 is 0, 1, 1 is 3, 1, 0 is 1, 0, 1, 2, 2, 0. Check in the options. So this, what we have done is, this is a number of base 4. Just check in the options which option you're getting. So this can be the right option, A can be the right option, B cannot be the correct options, and C can be the right option, and D cannot be the right option. So now we have to check between A and C. to check between A and C, I'm going to convert the same number into base 16, into a number of base 16. Okay, so for that I'm going to create group of 4 bits starting from the LSB. See, this is going to be one group. So what is 110 going to represent in a hexadecimal number system? So this number is equal to 14, and 14, as we know, is represented by E. Okay, then create one more group. This is going to be 2. This is going to be 7. This is going to be A. 10. This represents 10, and 10 is represented by A. Now we have 2 zeros left. So you know 0, if you append 2 zeros, it's going to be 0. This is insignificant. So the number that you got is A72E in hexadecimal number system. So the correct option is A. Let us look at one more question. This question was asked in 2005 for 1 mark in GATE examination. Okay, so what are they asking? They are asking for the hexadecimal representation of a number which is given in octal number system. So you know the trick, right? You're going to convert this number into binary first, and then from there we convert it into hexadecimal. So let us quickly look what is going to be the binary representation for the given octal number. 6 can be represented as 110, 5 is 101, and 7 is 111. So this is the binary representation of the given number. Now to convert it into hexadecimal, we are going to create groups of 4 starting from the LSB. The procedure remains same. 1111 is F. 1010 is 10, which is represented as A. Now you have 1 bit left, so I'm going to append some digit bits. I'm appending 3 zeros. So 0001 is 1. So what is the hexadecimal equivalent of the given number? It's 1AF, right? So A is the correct option.